Hello.
Hui, how are you?
Good, good, yeah.
All right. Hey.
So we're live. So hey everybody, welcome to the Web Server Frameworks team meeting for September 17th. We've got similar to most meetings, the same topics on the agenda, but we have this to get us started today. We're gonna first thing, which is a little bit new, which is talking about how Undici is gonna fit into this picture. You know, Robert, I don't know what you had wanted to talk about to present this, but maybe just it would be helpful for everybody to have like a let me stop my video because I think I cut out a little bit when I'm video on this internet. Just to give a little synopsis of what it is, you know, where the status is, you know, how it got brought into the Node.org and that stuff, and then we can jump off from there to discuss sort of the future topics.
Yeah.
So I'll hand off to you.
Sure, I can try. So I think Undici started like as an experiment to see how our next generation HTTP1 client could look and what kind of performance one could expect from that. Oh, Matteo is here.
Hey, hello.
Actually, I'd leave it over to Matteo then, since he's the one that started it.
What should I do?
Put him in on the spot.
Explain what Undici is and how it started
And just a second, sorry, I have a little bit of an issue. Okay, can you hear me?
Oh, yeah, you're good.
We're good.
Okay, sorry, I had a little bit of a, just a second. I need to move this. Here we go. Here we go. Okay. So let me go through Undici. Undici.
You can start with the correct pronunciation.
Hello. Okay. Yes. Undici. That's the correct pronunciation. 11. It's so this thing started a few years back when I was utterly frustrated for the extremely bad performance of Node.js HTTP client. Essentially, I was optimizing some client application, and they were doing a lot of microservices calls. And the net result was that it's making the HTTP request was the main bottleneck of their applications. It had two main problems. One was on the queuing side of those requests, so how the requests were queued up to be executed. Another one was on the bad use of keep alive and the bad use of keep alive of the Node Core HTTP client. This was recently fixed, I think, or at least improved in Node 14. And then, but also generically in all the dance between the agent and the rest of the logic. I don't know how many of you are familiar with the internals of Undici. You create the agent, which is kind of the connection pool that you put it in, but it's super generic. And so it actually slows everything down to a crawl. On top of that, we have a few bad guys in our thing, which are the same problem that we have on the server side, which are outgoing message and incoming message. And those are the same two bad guys that makes the server side slow. So essentially what it was happening was that we had a client, if we wanted to make a request to appear, the request is a socket, right? On top of that, we would layer this new readable on top of the socket to read the response. And this fake writable, which was an outgoing message to actually send the data in. And that's those two fake objects on top slow everything down by a level. So what Undici does, it does not create a stream in which you can pipe into and pipe from, but instead it lets you put in, oh, it is the body, it's a stream. And that stream gets piped straight into the sockets, for example. On top of that, it uses some interesting techniques of manipulating and generating the headers so that those are actually fast and not slow like the ones that we have in Node Core. Note that we cannot change any of those because otherwise we break everybody. So that's not like, we tried a lot of time between Robert and myself. We gave up. I personally have given up on the Node Core client in improving it in any way, or also on the server to some extent. It's extremely hard, if not impossible, to improve it. But there is a huge, like, the difference that we are seeing on Undici can be seen on a server-side implementation, because this server-side implementation has the same problems of the outgoing one. So there is probably a lot of code that can be lifted and moved around and reused if we want to go that path. That's kind of the gist of things. If you look at the API is significantly different from what you're used. So it's not stream centric, even though it supports streams. So you can pass in a stream, and you call and you do a request with parameters, and then it's called when you're getting something back. But it does not provide this pipe in, pipe out type of interface, which the original, whether the Node Core one provides, that is the source of all problems. And then there are some lower level and higher level stuff up and down. So I don't know if, Robert, well, you have anything. Instead of having the agent, the concept of an agent, we have the concept of a pool. So we have the concept of a client and the concept of a pool. So it's not that if you want to have an agent, you actually put something into a function method. But if you want to have a pool of connection, you actually create a pool and you use that pool, essentially. I don't know if there is anything to add, Robert, if you want to add something.
We also have pipelining support.
Yeah. Oh, yeah, of course, there is that.
Which is an advantage. And I can also mention my primary motivation for Undici was not the problems with the performance of the core agent. It was more like the behaviors, where it's trying to act like a stream, but it's not really a stream. And there's a lot of edge cases with destroying and when events are emitted or not, those kind of things, which are, yeah, I gave up trying to fix that in core.
You can't. The problem is we can fix them all if we decide to stop supporting Express backward compat Express.
Yeah.
That the bottom line is it's in that box. So they are all fixable if we decide that we can, because Express and Restify. Sorry, let me mention both. They both monkey patch some Node Core stuff internals. So essentially, everybody that starts plugging into the state of that writable object, and it will be really hard. And everybody else will probably need to do some shenanigans to support it. But for the ones that are monkey patching, it will be really, really hard to support both.
So I think we're blurring the lines here on this discussion between the strictly client portion and the greater topic, which we've been just starting the process of, which is providing that new underlying server layer. So do you see, since we're blurring that line, I'd like to continue on that because I think that's one of the main questions we have. Do we see, as we start shipping Undici with Node Core, that first becoming what we recommend to everybody to move to for the client, and second, then do we see sharing components like you mentioned, where we can just lift some code out of Undici and use that as sort of the core for our new server implementation?
I would not. So first of all, I am on the verge of shipping that with Core. The reason for that is by shipping it as an external module, we were able to iterate on it real quick at a speed that it would not be possible to do if it was in Core. So before moving it into Core, I would like to be really convinced, and we should be really convinced that, yes, that is stable enough to have a long, an LTS process, essentially, on it. Because there's no somewhere. So there will be less, we will be able, will not be able to bump somewhere as quickly as we currently have. Essentially, since Robert started working on it a few months back, and now we have done so many releases that it was essentially, it has taken what was my original prototype to something that can actually be used in production very well. So, and then we are also already talking about when maybe we should do a V3. So I don't know if, putting it in core and saying to people, use this in core right now might not be the best idea, but probably maybe in 6 months, 1 year time, when the API has become a little bit more stable and easy to use. But then we'll also have the polyfill in the Node.org. So the dependency from Undici to Node Core is very loose. It only uses the lower level bindings for LL HTTP and HTTP parser. So, which are not really public API, but on the other hand, we haven't just needed to have anything added there to support Undici. So there is that.
Yeah, I completely agree with everything said. I think that Undici should definitely have a few months, if not even a year, of road testing, maybe with well-known HTTP libraries that are currently on user level.
Yeah, exactly.
So we are already talking with GOT. I'm thinking about using in the Elasticsearch client library, so we can start actually using them in real world and provide fast feedback and then iterate on it.
So that's exactly what I want to talk about. I want to be able to use Undici in real life, large scale scenarios. And my question is about the API. As we talk here about having a server and a client implementation that works pretty much the same, do we see Undici API being a level above that? Or do we see Undici API being that API? Or do we see the Undici API completely shifting?
And this goes into the problem here that the way Undici works doesn't quite fit with James' plan of, next generation HTTP.
Yeah.
Yeah, it was built for one specific purpose: being fast at doing HTTP 1.1.
On TCP.
Or it also works on TLS, so it does the same thing on TLS. So
right, but there's also a proposal to do support HTTP1 on top of Quick.
Well, as long as it's a one node core streams, that will not be a problem. Okay, but the key part there is it takes a node core streams. You can probably also use it on a Unix socket if you want to. It runs on top of a node core stream. That's it. That's the only thing that it does. In this way, it's similar to our current HTTP 1.1 client that is can only run on top of HTTP 1 because of it's baked in. The concept of HTTP 1.1 are baked in the APIs. So there is some similarities between Undici and our current HTTP 2 implementation, in the sense that some of the logics are similar in certain ways, okay, but there is less in Undici. There is less streamy APIs. Considering that I maintain streams, that you should probably say a lot on what I think about our node core streams. So essentially, avoid them if you can. That's the TLDR. Use higher level things and so on, or lower level ones. Anyway, if it does not do any wrapping, extra additional manipulation, so that's why it's fast and why it's I think it's a good approach. Now the API can be iterated upon. I don't want to the API. Some part of the API can change, but the fact that it's it does not have that, fake incoming request and fake outgoing request objects. It's a key part of why this thing is fast. So this is a clear design decision on, if you want to get something performant, you need to avoid those type of things.
And going back to James API there, I mean, we could implement James API on top of Undici as it is now, but it would have lower performance than what Undici achieves at the moment. And to do the API Jamestown, then you basically have to rewrite the low levels of Node with the HTTP parser and the sockets and how those things work. I'm not sure if you've seen the API, Matteo, but it's basically, a duplex stream.
I haven't, but to be honest, I would challenge, like from what I've learned, like I haven't, so I cannot say. But from my understanding, if you want to get anything performant, you need to avoid. If you want something to be fast, you need to avoid streams. So this is the starting point. Like, streams provide a nice high-level abstractions, but providing a stream just as an in-between thing, it's going to cause more problems. Like, it's going to slow down. Okay, so every time you pass through a transform, you lose something, or a duplex, you lose a bit. So because it does buffering, you see, it buffers in and buffers out. And that you lose throughput, increase latency, you lose throughput, and generically it increase memory usage. So you need to be as close as possible to the socket, and or to what is the socket is.
Right. So if we're going to lose, so with HTTP 2 and 3 especially, I mean, I think we should focus on 3. I think we've agreed on that. The socket is not really something an end user is interacting with. And there's a bunch of stuff on top of it that's required to maintain the state
yes,
for the HTTP 3 connection. So I'm interested in what it would look like to try to do something similar on top of that.
Yeah, so this is slightly different theme between so they, depending on, so how we map those streams. So there is a quick stream at a lower level, protocol level, and then what we represent this quick duplex stream at the higher level. At the higher level, this is a duplex. The fact that this is a duplex is problematic in itself on a performance standpoint. Note that this is a construct that we might need to have. So,
sorry, just to be sure, by low level, you mean C++, high level JavaScript?
Yes.
Okay.
I mean C++ and JavaScript. So the difference is that if you implement a duplex, you have a buffering on the readable side and a buffering on the writable side. Okay, and this is what is causing problems on the HTTP2 implementation for a lot of things. And there is no way to avoid that, to be honest, in our current system. Okay, so I'm just mentioning this as this is the if you want to talk speed, this is the elephant in the room. So
so should we be engaging with James more on the current API? Because I don't think we brought those up in our deep dive last week, that's a problem. We were sort of asking, is this a problem? Is this the right API? He's still open to a lot of feedback. So if we think that we need those changes to make it ever performant, then this is the time we need to be,
I would he needs, so all of that needs to, I can probably sync with James later on next week or something and explain the key parts of my reasoning right now, but it requires some sort of different API from Node Core that is not a stream. It's not what we call it a duplex stream, okay? And it was on the original starting point. To give you a quick, there is a lot of reasoning and write-up on this topic, okay? So there is a lot of this stuff was initially discussed with Jeremiah. I don't know if any of you have seen this stuff, but Bob Streams, yes. And but I can't find it's just a second. I am let me try to find the repo, and there is Bob Streams were actually meant to solve these problems. So just so that you are aware. So I'm just providing some, yeah, that one. Yeah, thank you. So there is some more links here. So just to clarify where it's what problems is like, if you want to achieve that unlock some new level of throughput, those are the key. You need some mechanism that's not a duplex to transfer data back and forth. And because you need to avoid buffering essentially as much as you can on the higher hand on the JavaScript side. You know, that high watermark, blah, blah, blah.
Are the Bob streams compatible in any way with Node.js?
Zero.
Zero. So for example, you can't do the low level with Bob and then you read a file with the no streams and pipe the result into Bob. That is not possible.
It's easy to write. We wrote an adapter, I think, between the two. So it's easy to write an adapter and you won't lose any performance. So despite, you will lose performance because you're using the node streams, but that's what you will lose.
Okay, so it will be possible if you would like to go down this road to use this.
Yeah, but I would try to see what can be done without even exposing those type of things to the user. So if you look at the I think some part of the Undici API is actually a good lesson on this. So let me share my screen and let you see what I meant with this. So can you see? Can you see, folks?
Yes.
Yep. Okay. So yep. One of the key okay, so there are a few things. So for example, this is so there's various methods, okay? One is called request, and then there are streams and dispatch and so on and so forth. With the request, you can, you can specify a body, for example. So you can say, look, here is the body, and it will read the body. Now, this saves you, by passing it to the function instead of piping, okay? Note that with current Node Core APIs, you have this outgoing message object in between the real socket and your data. This object in between is the generator of the override. By removing that object, Undici just take the data from whichever source, which can be a string, a buffer, or a readable or something, and pipe it straight into the socket. These save us a lot of, this saves us this intermediary to move every single chunk of data, which is the.
So can I ask a question?
Yes.
So if the underlying quick stream is presumably doing the best it can to be performant, can't the higher level API do exactly what you're talking about without us going to James and saying, hey, no, I think we need a rethink?
So it is a problem. It is the key part. James API, if James API, it's a duplex, where is the direction where it's going right now. It cannot be, we can implement this, but it won't be as performant as it can be done if it allows us to pass a stream straight into it.
If you scroll up a little bit, Matteo, basically the differences between the benchmark here is how much streams are being used.
And
Yes.
so, the ask would be that James expose a non-streaming layer. It may be in addition to the existing streaming API, like that, which is effectively what Nodejs is doing, right? So if he did the same pattern where he had an underlying layer that had no duplex stream in between the consumer and the socket, the underlying socket, then we would build our lower layer on top of that, while it would still keep the streaming API for the people who want to have interop with other streaming APIs or, don't care about performance on that regard. Does that sound reasonable?
Yes, that is I'm opening a package, but yes, that's kind of the idea. Yeah.
Oh, I thought it was the NPM package. But basically, if you look at the benchmarks here, for example, in Node 15, the HTTP keep alive is the current implementation. Pipeline wraps Undici in a duplex, and you can see the performance there. Request returns a readable. Stream avoids the readable, and dispatch tries to avoid streams altogether. And those are the performance differences you get.
What did happen between Node 14 and 15 to have that massive difference? Because
I think it's something in streams. There's probably a high overhead on destroying streams in Node 14, which got resolved in Node 15. And some of the timing of some of the events are more sync in Node 15 than 14. That's just my guess. I haven't dug further into it. I was quite surprised myself.
Yeah, I'm super happy to see the result. Just curious.
So my question on whether, like, him exposing two APIs, I guess we could also just say no, expose one API that's just avoiding streams altogether. I do think that would be it might be just as approachable to folks who do want to go to that, straight to the quick, layer and don't need all the stuff we're going to add on top of it.
It's so, James can also expose a streaming API as much as it can allow us to essentially, when we called .respond, essentially when you call the .respond, just pass in a stream that can then be read directly and sent, read it directly and send it straight to the underlying quick socket. So essentially, similar to how .respond with file works right now. So instead of reading it, and putting it into the outgoing buffer of the duplex stream, you actually put it straight into the C++ layer, which will save us a step.
Yeah, that seems like a very reasonable ask, I think, especially at this stage with what he's shown, to say, like, that's what we think we need to build on top of. Would you be willing to champion having that discussion?
I'll speak with James, yes.
Okay.
I'll speak with James.
It would be very cool to attend the meeting if possible.
I'll try. I'll put. Let's try to schedule. I'll put on my to-do list to try to organize it in public. So
you're streaming.
So we can still see your screen.
Yeah, it's still streaming your screen on YouTube right now.
Oh yeah, okay, yeah. I'm streaming my screen on YouTube. Is fine.
Okay.
Let me stop sharing my screen. It was my calendar. So you've seen my calendar, right?
It was very pretty.
Quite insane.
This is my life. Okay. So you see where I am in trouble. And I only joined this meeting because I was in another meeting with Thomas, and Thomas said I needed to join.
Good job, Thomas.
Super helpful. So yeah,
Thank you, Thomas.
So
okay, so if you can, I'm happy to help facilitate scheduling it. You know, we did the deep dive last week, and I think that went well, and it wasn't too hard to schedule. So I'm happy if I do the scheduling portion, but you know, you have the busiest schedule, so it's oftentimes like just competing for your time.
yeah,
So
I'll sync with James and make a proposal on a time, and then hopefully it will work for everybody. I'm so sorry about it.
that makes perfect sense. And if we do that, and he can expose an API like what we've just described, I think then it really does open up the question for us of, can we build Undici on top of that API? Because if we can, then in theory, we could implement the HTTP2 and 3 support in the same methodology that Undici is following today. 1.1.
Ideally, yes. Ideally, it's so HTTP. So as for outgoing, it's to be honest, it will need to be rethought. I'm just mentioning from an API standpoint. So this API is not needed to be fast. Okay, it will be, so it's not needed for Undici to exist. We can implement it on top of any socket. Okay, but having it will speed things up immensely everywhere. So it's probably something that we want to add to Node Core for all the cases.
Will make sense to implement this in the next org for HTTP, road test it a little, and then backport it.
Yeah, yeah, but it will require the heavy patches on Node Core. Like this it's what the key part of what I'm envisioning. It's going to be a tricky beast to there is the stream wrap to touch. I don't know how much you like. Do you like, Robert? Do you like the stream wrap?
No, please don't mention it.
Yes, that's the guy so when I mentioned what is the problem is stream wrap.
So, oops, sorry, I was muted. I think we have a planned solution here for how to get around some of those challenges, and that is start building on top of only the new stuff for our HTTP Next and leave all that old stuff alone for now. And then once we've proven out all of these new APIs, we can start seeing what makes sense to pull back into the existing HTTP, HTTPS, and HTTP2 layers, if anything, and maybe not. Maybe we just deprecate them and move to whatever HTTP Next ends up being someday. But I know that'll be tough.
The only one that probably needs to be deprecated is HTTP2, but as a thing. But the HTTP1 is going to stay there forever. So providing a really fast API for HTTP1 on the server would actually improve a lot our current our Node.js user base.
Right, but the plan is for the new core parts that James is working on to support HTTP1 over TCP as well, because the abstraction layer will abstract away the differences there. So I think that there will be breaking changes, but I think that we can achieve a place where we do deprecate HTTP as it is, the package, you know, as it is today, with a full replacement.
I think it's a nice goal to aim, but definitely something we should talk about somewhere in the future. Start with the new implementation, maybe from scratch. So the less we use, the better. And then if we see that we can reconcile something to avoid do a hard-breaking change, even better.
Yeah, I agreed.
I mean, to mention in context, from what I understood from James is he envisions rewriting the TLS and the TCP stacks in Node Core as well. which seems like I'm not sure how he's going to have time for everything. But that might also affect how something like Nodejs would be implemented.
Well, yeah, that is essentially having, so we can improve if we add the level of support that type of API that I would like to have. We can even bump it up a notch, bump it up a notch even on that side of things because of that passing. So yay.
Cool. So I think next steps is you're going to propose a time for us to have a James on that API change.
Yeah, I'll think with James first, and then let's schedule something.
And then if we can assume that we will make progress on that front, do we want to continue the rest of the meeting with discussing the APIs we want to expose at the higher level, or do we think that that might be too dependent on whether or not, you know, we have these changes in?
If I can give you my take, it's talking about high-level API without knowing what low-level API means makes it will provide very hard to make good decisions.
Yeah, that's what I was worried about. But I thought we left the deep dive with a pretty with an understanding of many parts of it. Do we?
I mean, if we go with the way James showed us during the deep dive, I think we can continue with the high level discussion. But that goes with the assumption that it's a duplex, etc., which is kind of what Matteo recommends we move away from.
Okay, so how about we wait the meeting with Matteo and James to discuss the low-level API, and if we're going to have duplex strings moving forward or not, or if we're going to have duplex strings and a different API, and we can move forward after that. How about that?
Yeah, I'm not opposed to that, but I would like to question, and maybe people have you know, insight here. Couldn't we have it? We could make a decision at the high level to not make the API a duplex stream, since we know that's sort of the end goal. And even if the underlying is a duplex stream, we just do the mapping, and then we work toward a future where it's not a duplex stream as a, you know, secondary goal. Like, I don't think those things have to be tightly coupled as far as progress goes, right?
No, that's true. I mean, the thing, I mean, we briefly discussed it with James, that, I mean, even if we disregard the performance issues with a duplex on the low-level implementation, I saw problems with it because you keep, you know, as soon as you start working with a duplex and with middleware, you end up unwrapping and rewrapping the readable and writable parts into a duplex and just kill performance that way.
So to me, though, that really leads to, we should have the non-streaming sort of context object approach as sort of one of our, you know, top options as a goal, right, for that API, and then start working from there. Because we can do that where it's not a stream and it's just a, you know, a response or request context.
Plain old object.
What'd you call it?
A plain old object. The fastest thing you can have in JavaScript. So
I think in the what issue was it that I posted an example inspired by Nodejs, where you basically get a request is just an object with the headers, body, and status code, and you return an object with the status, headers, and body object. Where was that?
I think it was in our little gist conversation, I think, right? Wasn't it? You were like, I really like, the more I look at it, the more I like this. And it was, oh, was it? Okay, maybe I'm. Yeah.
Let me just find it. Frameworks. Node.js.
I mean, if we start with that approach and start prototyping out some of those things, I think that would also make if we could make a strong case for that, and then look at where the gaps are between that high level goal and the low level APIs, I think that would give us a lot more concrete, you know, arguments to make with James. Yep.
So this is the example, right? But that breaks down as soon as you you know, start talking about trailers and push and what was it? Trailers, informational headers, and push. And
Right.
body here could be something that's not a stream as well, I guess.
But I think we could just make those not plain old objects, but just very thin classes, right? And we get effectively the same result. You could even structure in the exact same way because, you know, it'd work. And then if you don't need those, great. If you do, then you call, you know, dot trailers or whatever we decide the API should be.
Yeah. But in the best of the, I mean, in best of the worlds, it would be nice, like on Nodejs, that we have an API that is not streams. It's just a plain old function that gets called. That streams can be implemented on top of. But I'm not sure how that would look on the server side. Actually, there is one thing missing in Nodejs as well here in dispatch, a way to send a body that is not a stream, but you know, it just has a, you know, read, give me more data function.
I will be less concerned about using those as about having it as a stream and not having about supporting a stream there. So I think supporting a stream there would be mostly fine, mainly because we are going to read them somehow from somewhere. So and if we can support an iterator or an async iterator over there, then we are good. Okay, so to be honest, I would like overall I would streamline everything to async iterators and be done with it. So yeah,
Probably or buffer or something like that as well. But
yeah, or buffer.
Effectively the same Nodejs API that we're talking about for body, we would just throw in here, right?
Well, this is incoming, so it's not true. This is not true. So essentially, the body would be a readable here, or because it won't be parsed.
Sorry, yes, I meant for the return value, not the.
Yeah, not the incoming one. So the incoming one, to be honest, can also potentially be an async iterator. If we decide to, if we decide that's faster and better, it might just be an async iterator. I don't know. I would still use a readable, but we lose something on receiving, on parsing the body.
One of the things I remember who, I think it was Brian English maybe brought up, was looking at adding a .consume or some variant of that to just consume the entire body to the stream, which would be really nice in this case, since like the 90% use case here is read the entire body and parse it as JSON. So it would be, and with an async iterator, you wouldn't be able to expose that API, whereas
why wouldn't
you can?
You'd have to.
You make a function.
Yeah, you would make a function, right? It wouldn't be on the.
No, you can put it in the. So if you put it on the iterator, if you share an iterator object, an async iterator object, you can create them as a class, and then you can add whatever method you want.
Okay, yeah. Okay, I see what you're saying here now. Sorry, I was thinking of it.
So it's not. It might not be a stream. A pure async iterator. It might be our own variation of it.
Yeah, cool. Which that resolves my concern completely. So yeah.
So overall, it's from my point of view, I would try to keep that type of object-based API. So.
And so just to be clear here, you put middleware because we were sort of mixing the conversations between framework level and lower level, but presumably this would just be the, you know, it would be like .handle or something on the server, right? Maybe not that API explicitly, but yeah.
So if that is the .handle, don't we have to return a status code?
I mean, in HTTP2, the status code is part of the headers. It's the, status pseudo header. But I mean, that's details, whether you have that explicitly or as part of the headers. Yeah.
So I think presumably we would have, since we're going to go with like a layered approach, I think we would probably want to expose no helper at the lower level and make it, really explicit. And then if we have a higher level API that took like that, again, a dot status method, which is basically what every single framework has, like, I feel like we should just take our cue from there and add that in the higher level APIs.
Yeah, that was my thought here. So just keep it as minimal as possible.
So
I might even go as far as, having headers as an array here.
I think, again, at the lower level, I think this is where we want to go for, is shoot for high performance and pick the best usability option of the high performance, versions. But I think we would then just wrap this method with a higher level API that took, the response, the context object would have like a dot status method, which would know whether the underlying request was HTTP 1, 2, or 3 and set the proper value accordingly, right? So it would do the pseudo header for HTTP 2 and 3 and the, property on the object for 1 or something like that.
Matteo, do you think async iterators are performant enough?
I would need to benchmark.
Because the benchmarks, I even opened an issue on Chromium. Like I was surprised that the handwritten async iterator you made is actually faster than async generators, for example.
I know. Well, I know. I don't know why. So we replaced it because you benchmarked it. It was fast enough, right? But
it was fast enough, but it wasn't faster, which was surprising for me.
Well, my stuff was stupidly highly optimized.
Yeah.
So it was on the side of the unreadable. It was a mess to maintain because nobody besides me, probably you, after a year, was able to actually take that code and fix a bug there.
Yeah.
It was a nightmare. In order to reach that performance, it was a nightmare. So they allocate a lot. They use a lot of memory, but I'm not necessarily convinced that an async iterator. So it might well be that an async iterator is actually faster than a readable.
At least I think in theory they could be significantly faster with sufficient V8
magic. So the key difference is how it will do the buffering. So if the buffering for that async iterator is implemented correctly, then it can probably be faster. We can prototype this in Nodejs if we want to take.
Also, the nice thing about the async iterator is that you are hiding this problem from the user. So you can even change the implementation behind the async iterator. So how you are reading the data, and the user will never know.
Yeah, but the key difference is how we do the buffering. So if you put a readable in between, you are buffering 16K of data in there. If you put an async iterator and you don't start reading until somebody starts reading from that async iterator, you're not buffering anything. Which is what gives us speed boost, essentially. And so that's kind of it. Anyway, I got to go, folks. So it's time for goodbyes. So sorry about this. It was very fun. Bye-bye.
Bye-bye.
So could we maybe move on to another, topic that might not be such a deep dive on whether the async iterator performance, which is great, but those are sort of details I feel like can come secondary a little bit later. The return a response pattern has sort of one interesting drawback, in my opinion, and it's that you have to presumably import a separate, the constructor for the response. One thing I like about the HTTP2 API is the .respond method, where it just comes in on the context and you're not like in every middleware file having to import, you know, HTTP response or whatever? Do we think that there is, do we think that it is fine to do that low level API like that and then move the any sort of helpers we might want to expose to the higher level, or do we need internal consistency and just, you know, want to require every person to import HTTP.response into every middleware that returns a response, right? Is my question making sense to everyone?
Yeah. I mean, the reason I prefer the return way of doing it instead of doing a respond is theoretically you can call respond twice. What does that mean?
Well, so my thought here was we would have the respond method actually return the response, not do the response. So you would do like respond with or something, and it would return you a response object. You can then return from your handler function or not if you don't want to respond.
And what happens if you call it twice?
It would return you 2 new responses, and you'd return. You can only return one of them from the function, right? So.
I
okay,
see.
OS. So you still wanna return, but you want like a utility
Factory method
function to create an object.
Yeah, and it's
like,
specifically to avoid the problem of everybody having to import HTTP and then pull off the response from it to create it in every file.
But why
so they would come in with the.
Why would you need to do that and we can't just return a plain old object? Like a Robert's example right there. It's just returning a plain old object.
I think it's specifically for those 3 features. Well, maybe not. I wonder. Let's see. Could you do?
I mean, you could do trailers as a promise.
Yep. Okay. That could
you
work.
You could do informational as an async iterator. And you could do push here as well as an async iterator or something. I'm not sure about the details.
You would create a push off of the you would actually do on the incoming response object, you do like a dot push method, which would return to you the push response, right? Okay. Okay. Yeah, that might work.
Something like that, and then you do in there. I'm not sure informational. Yeah. So there's different, you know, ways of doing it. I was playing around with, you know, because basically you first return headers and informational headers, then you return a body, and then you return trailers. So that's also one way of looking at it. Yeah, so I think it's possible without having to create a, you know, a lightweight class, a response class. So we just return an object that that has the things that are required.
Yeah, if we can do that, then I'm fully on board with that. And it looks like we probably can.
Yeah, I think the only thing that is a little bit unclear is informational headers, where they fit in and how. I mean, you could have informational headers if you implement headers as an async iterator.
Could we make that handle either an async iterator
or an array,
or array or object? I mean, I like the low level API. We have to consider performance. So would it be performant for us to accept? Well, if you had the option, then you'd choose whichever one mattered for your use case, right? Like, yeah.
That's what we do in Nodejs at least. So you can pass an object or an array. Sorry, I have to take this.
From a performance point of view, instead of returning a plain old object, creating a class definitely helps. This is something we experimented a lot with in Fastify, and if you have a class, the shape of the object will always be the same, and then V8 internal, we will optimize it a lot. So returning the new response object might have good performance implications, but yes, you will need to either have a factory method or import it from a package every time.
Do you have benchmarks on that? Because that could, you know, help inform how impactful.
I think we did, but I fear we lost them. But I can try to dig it in and create a benchmark. Yes.
So okay.
But still, sorry to interrupt. One of the reasons why Fastify is very, very fast is also for how we are creating the request and the response objects. Those are all classes, and every time we need to add a property to these classes, we add this property to the prototype before start listening to requests. And as a result, every time this object gets created, this property is already on the prototype. So we are not changing the shape of the hidden class, how it's called in V8, behind the scenes, which means that then the object will be faster because V8 knows how the object looks like, and then we are only updating its properties. So we are faster, it's fast accessing the object, it's faster the creation of the object, and so on. But it's a little bit more verbose. This is the...
I know I did some experimentation in Express and saw a pretty noticeable difference, even though Express is already doing some really bad things in that regard. So I would say that if we think that that's going to make a meaningful performance difference, or even if it is incremental performance difference, and we like the API where it's a factory method, then I think we should just probably go that route.
Sorry, guys, I'm back.
Oh, I'm sorry. I have to jump off right now. I have another meeting. Okay, see you.
Yeah, same here.
Yeah, we're at
I need
time.
to go
So,
to dinner.
let's maybe continue this, but I think we made good progress. So we'll follow up with Matteo and James. I haven't looked at a lot of your comments, I guess, Robert, now that I'm seeing these, so I'll hop in there and maybe we can continue the conversation in this issue. And then next week is our next meeting, or is it 2 weeks, I think? Probably, okay, yeah, 2 weeks. So so maybe next week we'll be able to find a time to schedule the deep dive stuff with Matteo and James, and then we'll follow up again. Excellent.
Is there any chance that the next meeting could be 1 hour earlier?
I don't see why not. I don't personally have any.
Then I can, now I canceled my other thing, but I'd rather not.
I doubt, does anybody on this call on the Node community committee? So we might not be able to stream it because it would be overlapping. And so I think they only let one stream on the YouTube, but I mean, that's fine as far as I'm concerned.
Cool.
Yeah, as long as we record it in any way.
Yeah, and we can upload it after, but okay. Excellent. Well, I'll end it then. See y'all next time.
Cheers.
Bye.